Section 2.6, solving quadratic equations. Okay, so the last section we were solving linear equations and inequalities. Here we're going to turn it up and go towards quadratic equations. So real quick, we've dealt with quadratics before, but just to be clear, when I say quadratic, I'm talking about an expression that has 2 as the highest exponent on a variable. Okay, in other words, x squared, right? That's going to be the term with the highest exponent. Okay, so with that in mind, let's jump into it. So there's a few things we have to keep in mind. One of the things that allows us to solve a quadratic equation is the zero product property, okay? And so the zero product property is kind of an obvious one, but it's not obvious until it's pointed out, okay? That's usually how it goes. So notice here, if something times something equals 0, so two things multiplied together to equal 0, the only way that can happen is if either this is a 0 or this is a 0, right? The only way you can get 0, if this was 2 times something equals 0, it'd have to be 2 times 0, right? There's got to be a 0 being multiplied in there somewhere. That's the only way it'll happen. So if something times something equals 0, the first thing equals 0 or the second thing equals 0. That sets us up with two equations, right? It kind of takes this one equation and gives us two equations. Okay, all that to say, look what we have right here. We have something times something equals 0. The zero product property applies here. So 9x minus 8 could represent the 0, or x minus 2 could represent the 0. Notice in both cases I have these two simple equations, right? And I can solve them pretty quickly. 9x minus 8. Okay, I will add 8 to both sides. That will give me 9x equals 0 plus 8 is 8. Then divide both sides by 9 and get 8/9. That's one solution. I could add 2 to both sides on the second equation here. 0 plus 2 is 2. There's actually two solutions here, right? If I plug in 8/9 into this right here and here, I'll get 0 times something. If I plug in 2 here and here, I would get something times 2 minus 2 is 0. Okay? So in either case, I get a 0 that appears in the multiplication. The result ends up being a 0. Okay? So 8/9 and 2. Okay, 9y squared equals 7y. Let's talk about that one as well. Okay, again, we're going to use the zero product property in a second. Notice how this does not quite mirror this, right? It's not something times something equals 0. Okay, so what I'm going to do is get this thing equal to 0 by subtracting 7y from both sides. I'm going to get rid of anything that's on that right side, any terms, by subtracting. Okay, 7 minus 7y is 0. But I have 9y squared minus 7y equals 0. Notice I did not put these two together. They're not like terms, right? Remember, y squared, y, not like terms. So keep them separated. Looking at it like this now, 9y squared minus 7y. They both have y in common, so I'm going to factor it out. Okay, y is a common factor. If I factored out y, I get 9y minus 7. Now, something times something equals 0. The zero product property applies. So, y equals 0, 9y minus 7 equals 0. This one's solved for us. Y is by itself, so we're in good shape here. On this one, though, we need to solve for y, so just like in the last section, we're going to add 7 to both sides to get rid of the constant term. 9y equals 7. 9y is a variable term. It has 9 as a factor, so divide both sides by 9 and get 7/9. So this one has two solutions, 0 and 7/9. Okay, it's typical for a quadratic to have two solutions. Okay, it's possible possible that you get the same solution twice, but that doesn't happen as often. Okay, anyway, so those are some pretty straightforward problems. I want to point out real quick, when I refer to a quadratic equation in standard form, I'm talking about this. It's in ax squared plus bx plus c equals 0. So in other words, you have your x squared, you have your x, you have your constant term, and it all equals 0. That's standard form. You want your quadratics in standard form in order to solve these types of equations, okay? Oh, and also a, b, and c, in case you need to be reminded, those are just numbers, right? Okay, so this 36x squared plus 6 equals 30x, that's not in standard form. Okay, I need it to equal 0, so the first thing I'm going to do is subtract 30x from both sides, and I'm going to be careful to make sure I put that minus 30x, that new term that's going to appear, in the middle, right? I already have the x squared term, I already have the constant term. What's missing is that term that's in the middle, right? So I'm going to make sure to put it in the middle. This is the bx term. Okay, so now I have to factor it so that way it's written out as a product, as things all multiply together. So 36x squared minus 30x plus 6 equals 0. Hopefully you recognize right away that these are all divisible by 6, right? We have a common factor of 6. So I'm going to factor out a 6, my greatest common factor here. Okay, so if I divide all this by 6, I get 6x squared minus 5x plus 1 equals 0. Okay, let me show you something kind of new. I was debating whether or not to do this, but I'll go ahead and show you. You have something times something equals 0, right? You can eliminate this factor right here by dividing both sides by 6. I'm going to do that because that just makes my problem a little bit easier to deal with. Okay? As long as it's a number, you can divide both sides by that number. You don't want to divide both sides by x, right? You're going to eliminate one of your potential solutions if you do that. Okay, so don't do that. But notice how I made this problem a little bit easier to work with. I'm going to bring it back up here because I want to see if I can fit this in one little area. All right, so I need to factor the left side. So it's something times something equals 0, and then go from there. All right, so AC method says multiply 6 times 1 together. 6 times 1 is 6. I need two numbers that multiply together to be 6, that add together to be negative 5. Okay? And so that's going to be negative 2 and negative 3. That doesn't look right. There we go. Okay, so use that to split my middle term into negative 2x plus negative 3x. And notice I'm going to keep bringing down that equals 0 so I don't forget what I'm trying to do here. Okay, let's group together the first two terms and the last two terms. The common factor between 6x squared minus 2x is 2x. If I factor that out, I'm left with 3x minus 1. Negative 3x plus 1, the only factor there that those have in common would be 1, but since this is a negative in front of that 3 there, I'm going to take out a negative 1. Okay, so factoring out a negative 1, I'm left with positive 3x minus 1. All this equals 0. Okay, notice a couple of things I want to point out real quick. I'm kind of going through this a little bit quicker than I would ordinarily. You may need to go back to the factoring section to review that, okay? This section combines factoring and solving linear equations, right? You may notice that. So maybe go back and review those if this is going too quick. Okay, anyway, so 2x times 3x minus 1 minus 1 times 3x minus 1. 3x minus 1 is a common factor. 2x minus 1 is what's left over when you factor out the 3x minus 1. Okay, so we have 3x minus 1 times 2x minus 1 equals 0. The zero product property now applies because we have something times something equals 0. 3x minus 1 equals 0. 2x minus 1 equals 0. Let's solve these both. On the first one, I'm going to add 1 to both sides. x equals 1. I'm going to divide both sides by 3. X equals 1/3. There's my first solution. On the other one, I'm going to add 1 to both sides. 0 plus 1, of course, is just going to be 1. 2x comes down. Divide both sides by 2. X equals 1/2. So those are my two solutions. Just a little minor note. Whenever we finish factoring this, 3x minus 1, 2x minus 1, if I had not divided both sides by 6 over here to get rid of that 6 on the outside, that would still be included here. And when you go to apply the zero product property, let me kind of do this to differentiate those. When you go to apply the zero product property, you would have to say 6 equals 0, 3x minus 1 equals 0, 2x minus 1 equals 0, and of course this one's nonsense, so you would ignore that one, right? So you'd still end up with the same thing. I just wanted to demonstrate that the 6 is still there if you want it to be. Okay. Let's talk about the square root property. You'll notice that in this, or the next two examples, it's the same equation, okay? And there's a reason for that. So the square root property, we'll talk about it in a second. Actually, you know what? Let's talk about it now. Let's talk about it now. X squared equals a number. Okay, if x squared equals a number, then x equals the square root of that number and negative square root of that number. Okay, it equals both of them. There's two solutions there. Okay, so I'm going to actually do this example two different ways to demonstrate why that's the case and how the square root property can make things easier for us. So if I'm trying to solve 100x squared minus 81, the first thing I need to do is make sure it's equal to 0. So I'm going to subtract 81 from both sides. Okay, again, if you're dealing with a quadratic, you want it equal to 0. In other words, if you have an x squared, get it equal to 0. Okay, 100x squared and 81 are not like terms, so I just kind of kept them separated, just brought them both down. Now, you may recognize this from the factoring section. This is difference of squares, right? 100x squared minus 81 equals 0. Okay, well, 100 is 10 squared, and 81 is 9 squared, so this factors as 10x plus 9, 10x minus 9. Okay, so the zero product property now applies. I have something times something equals 0. 10x plus 9 equals 0. 10x minus 9 equals 0. Alright, I'll go back up in a minute. Let's solve both of these. Subtract 9 from both sides. 0 minus 9 is negative 9. Divide both sides by 10. X equals negative 9 over 10. There's my first solution. Add 9 to both sides. 10x equals 9, because 0 plus 9 is 9. Divide both sides by 10. X equals positive 9 over 10. Okay, let me point something out here. These are the same numbers with different signs, right? 9/10 and negative 9/10. You have a positive and a negative. You have a positive and a negative. And also notice, right, so in the zero product, or in the square root property, you have a positive answer and a negative answer. Also notice, the square root of 81 is 9. The square root of 100 is 10. Okay, in other words, 9 times 9 is 81. 10 times 10 is 100. Okay, let's use the square root property to solve the same equation. Okay, so 100x squared is equal to 81. In order to use the square root property, I need to actually have x squared by itself. So this is one of the only cases where I'm going to get rid of the number attached to the x squared. So 100 divided by 100 cancels out. X squared equals 81 over 100. Okay, the square root property applies. X squared equals a number. X squared equals a number. Okay, so then what does x equal? X equals positive square root of that number and negative square root of that number. X equals positive the square root of 81 over 100 and x equals negative square root of 81 over 100. Okay, this should start to look familiar, right? Because the square root of 81 is 9, and the square root of 100 is 10. The square root of 81 is 9, the square root of 100 is 10. So there's our two answers, right? Notice we used the square root property this time to get that. Okay, so the square root property. That will bring up some other types of problems, some other types of numbers. So it's been a while since we've encountered a new type of number, and here we go. Okay, this is set up for the square root property now. X squared equals 90. Okay, so if that's the case, then x equals the square root of 90, and x equals negative square root of 90. Okay, the square root of 90 is an irrational number. Okay, so we've dealt with rational numbers, which were numbers that could be written as fractions. This is the first time we're encountering, I think, a number that cannot be written as a fraction. The square root of 90 is one of those, right? So what do we do with that? Well, we need to simplify it if we can. So let's talk about that. If I take 90 and break it up, 90 is the same thing as 9 times 10. Okay? 9 is the same thing as 3 times 3. There's my prime factorization there. 10 is the same thing as 2 times 5. There's my prime factorization there. So 90 is actually the same thing as 2 times 3 times 3 times 5. If I multiply that together, it equals 90. Okay, so what can I do with that? Well, the square root of 90 is the same thing as, and I'm going to rearrange these a little bit, 3 times 3 times 2 times 5. This pair of 3's is the same thing as 9, right? And this 2 times 5 is the same thing as 10. This is the same thing as the square root of 9 times the square root of 10. And the square root of 9 is 3, because 3 times 3 is 9. Alright, so I kind of drew arrows all over the place. I don't know why I did it that way, but the point is, the pair of 3's end up coming out, okay? And you're left behind with whatever's not paired up. That's how you simplify a square root. Okay, so I don't know why I drew the arrows all like this, but there we go. X is equal to 3 times the square root of 10, and of course, negative, right? Negative 3 times the square root of 10. Those are my two solutions. Okay, so this is an irrational number. Okay, this is the best we can do with irrational numbers. Now, that's if I wanted the exact value. If I wanted an approximated value, I would just type it in a calculator and see what I get. Okay. All right, let's do another problem very similar. X minus 2 squared equals 24. Okay, so for this problem here, the square root property still applies because you have something squared equals a number, right? This is like our x right there, equals a number. So whatever is being squared, in this case it's x minus 2, whatever is being squared is positive square root of 24 and negative square root of 24. Okay, so let's see if we can simplify the square root of 24 and go from there. Or actually, let's get x by itself first. So I'm going to add 2 to both sides. Keep in mind that if something's under the square root, it's its own number. You can't put those together. Okay, cannot put those together. So this is just going to be positive 2 and positive square root of 24. You could put the square root of 24 first if you prefer. This is how I like it. Okay, so, and then I'm going to do the same thing over here. I'm going to add 2 to both sides again, keeping in mind that I cannot put these two together, so I end up with x is equal to 2 minus the square root of 24. Okay, 2 minus square root of 24. Let's see if we can break down the square root of 24. Okay, so 24 is what? 2 times 12. 2 is a prime number. 12 is 2 times 6. 6 is 2 times 3. Okay, keep in mind, every pair of numbers is going to become a perfect square that's going to come out of my square root. So the pair of 2's will come out. This 2 times 3 will remain behind. 2 times 3 is 6. So the square root of 24 is the same thing as 2 times the square root of 6. So my final answers, these are kind of strange looking now. 2 plus 2 to the square root of 6. 2 minus 2 to the square root of 6. Okay? Both of those are considered exact solutions to our original equation. Okay? Again, if we wanted an approximated solution, we would just type that in the calculator. Okay, let's keep going. X squared plus 50 equals 0. Alright, I want to use the square root property here, so I'm going to subtract 50 from both sides to get x squared by itself. X squared is equal to negative 50. Now, let's go back. X squared plus 50 equals 0. This right here. That looks a lot like difference of squares, right? That was sum of squares, and we said that we couldn't get a solution for that, okay? Or at least we may have said that at some point. That would be a lie. We actually can have a solution to that, so we're going to talk about that now. Okay, the square root property says x equals the square root of negative 50, and x equals negative the square root of negative 50. Okay, so the problem here is unless we invent a new type of number, we cannot have a square root of a negative. Okay, we can't have the square root of negative 50. Okay, so that's where we're going to come up with something new. So keep in mind, first of all, 50, well, no, let's deal with the negative first. Anytime you have a negative outside of the square root, it will come out as an I. I know. What? It comes out as an I. X equals I times the square root of 50. Okay? X equals negative I times the square root of 50. Keep in mind, this negative is this negative, right? These are the negatives. This I is this negative up here. Okay, what is going on there? We're not going to get too into it. All I'm going to say here is that when you see I squared, that equals negative 1. Okay, it is they call it an imaginary number. I don't like calling it that because I think that's misleading. It's part of complex numbers. Okay, so we have I square root of 50 and negative I square root of 50. Now let's break down 50. The square root of 50. 50 is 5 times 10. 10 is 2 times 5. We have a pair of 5s. I can't really box those in the way I wrote it out. But we have a 5 on the outside, and we have a 2 left on the inside. 5 square root of 2. So my final answer here is 5i times the square root of 2 and negative 5i times the square root of 2. Another way to write this out is 5 square root of 2i and negative 5 square root of 2i. Notice you could put the I at the end. That's probably better, but there's always a mistake where people accidentally make this line too long and it looks like the I is under the square root, and that's not the case. Okay, so just be careful if you decide to write it this way. Make sure that it's clear that the I is not under the square root. Okay, weird stuff, right? Don't stress out. Simplify the square root of 50 like you've done already. The I that you're worried about is just a negative under the square root coming out. Okay. X plus 6 squared equals negative 5. Okay, here we go. Let's use our imaginary number I, right? X plus 6 is something squared equals a negative number, so that x plus 6 could equal the square root of negative 5, or x plus 6 could equal negative the square root of negative 5. Okay, I'm going to subtract 6 from both sides. Keep in mind, I got to keep that separate from the square root. Negative 6 plus the square root of negative 5. Over here, I'm going to subtract 6 as well. Keeping in mind that I cannot put together the square root and the negative 6. So negative 6 minus the square root of negative 5. Now, negative in the square root is going to come out. So I'm going to kick it out as an I. I'm going to kick this one out as an I as well. And that will give me my two solutions, negative 6 plus I the square root of 5, and negative 6 minus I the square root of 5. Now you may see this notation. That just is the shorthand way of writing both of them, right? You have the plus and you have the minus because that's the only thing different between the two. Okay, so that's also a way to do it. Okay. Let's talk about the quadratic formula. This thing looks ugly. Okay, let me preface this by saying the quadratic formula works all the time. Okay, you can always use it no matter what. If you don't feel like factoring and you'd rather use this formula, it'll work. Even though it's kind of ugly, it's really not that difficult to work with. Okay, but when do you have to use it's the question. So let's say I was trying to solve this one the way I know how, using the AC method and factoring, right? Well, I'd multiply together. 4 times 1, I get 4. So I need two numbers that multiply together to be 4, but add together to be 6. Well, it doesn't take long to realize those numbers don't exist. Right, I'm running out of options here. So there are no integer pairs that'll work for me. So whatever would work for me, those would be some complicated numbers, either complex numbers or irrational numbers. I don't really know. So what I'm going to have to do then is use the quadratic formula. So if you can't factor it, quadratic formula. All right, notice it's in standard form, right? ax squared plus bx plus c equals 0, which means that a is 4, b is 6, and c is 1. Well, those are the numbers I need to plug into the formula. X equals negative b, I'm going to leave it blank, plus or minus square root of b squared minus 4 times a and c, all that over 2 times a. I want to point out that plus or minus sign, right? Remember, that means that you have two answers in one. You have the plus and the minus. Just like in the last example where we had plus and minus. It represented two answers. You don't want to do that twice to get the same exact numbers, right? Okay, the only thing different is going to be a plus or a minus. Okay, so b is 6, negative b plus minus square root of b squared minus 4 times a times c over 2 times a. Just plug all the numbers in. Okay, now I don't have to look at that formula anymore. I see three things that need to be simplified. All right, those three. So I'm going to do them one at a time. This one's the easiest one. Negative 6. Literally, it's exactly what it sounds like. Negative 6. 2 times 4 is 8, so I'll put 8 on the bottom here. All right, let's see. 6 squared is 36. And 4 times 4 is 16, times 1 is 16. So that's going to be under the square root. And 36 minus 16 is 20. So negative 6 plus or minus the square root of 20 over 8. If only we were done here, right? If only we were done right here. But we're not, right? Because the square root of 20 may be able to be simplified. So off to the side here, I'm going to say, all right, 20 is 2 and 10. 10 is 2 and 5. Pair of 2's. So 2 the square root of 5. Okay, so check to see if you can simplify the square root, because that means that you might be able to simplify your entire fraction altogether. Negative 6 plus and minus 2 the square root of 5 all over 8. Okay, this is the last part. 6, 2, and 8. This is a new type of fraction where you have two terms in the numerator and a single term in the denominator. 6, 2, and 8 are all divisible by 2, so divide them all by 2. Negative 6 divided by 2 is negative 3. Plus minus 2 divided by 2 is 1. Square root of 5. Of course, you wouldn't put the 1, so I'm going to get rid of that. Just like you wouldn't write 1x, you would just put x. All over 8 divided by 2 is 4. Those are my two solutions. Now again, let's go ahead and write it out just so we remember what this means. This means x is equal to negative 3 plus the square root of 5 over 4 and x is equal to negative 3 minus the square root of 5 over 4. Okay, and that is how we'll solve quadratic equations. So that'll be section 2.6.